So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be proving this identity actually. You know what? I have recently uploaded a video on my channel that is the Quantum Mathematics, right? And I'm not talking about this one, but I'm talking about this one. So basically it's generalizing an amazing infinite sum, right? So basically this is your like stuff that we have proven in that specific video, and we literally did take 54 minutes and 11 seconds to just complete that video. So yeah, it was kind of difficult and lengthy. It wasn't difficult, but it was literally lengthy. And you know what, in this specific video I have used this identity as its base, right? And I did proved actually. You know what, in this video I have proved this thing, and I'm just going to repeat the same step in this video, but it is specifically for this identity, not for that one, right? So basically yeah, it's a separate and independent video actually, in which we will be talking about the proof of this identity. So now let's just talk about this, and I think I just gotta remove this tab. Okay, so we have to talk about the proof. You know what, to prove this down, what we're gonna do here is we have to let z equals your arctangent of theta, right? And now from here we can say that your theta is tangent of z, right? Okay, and now we know that tangent of z can also be written as sine of z over cosine of z. And now let me just talk about this formula. Basically this is e to the iz equals cosine of z plus I sine z. So basically this is your Euler's formula, an amazing formula that can exist, I would say. And now if we replace our z with minus z here in this equation, so we would be having e to the minus iz as cosine of minus z plus I times sine of minus z, right? And we know that cosine of minus z is just cosine of z, and sine of minus z is minus sine of z, because cosine function is an even function and sine function is an odd function. So for that case, so from here we can say that it's equivalent to cosine of z minus I times sine of z. And let this be your first equation, and this be this is your second equation, and this be your first equation. Wait a second. Yeah, and now what I'm gonna do here is adding the first and second and subtracting the first and the second equations here. So basically adding up, so it's e to the iz equals cosine of z plus I times sine of z, and e to the minus iz equals cosine of z minus I times sine of z. Now just adding them up, so we would be having e to the iz plus e to the minus iz equals to cosine of z, because take a look at this, these two terms are getting cancelled out with each other, and from here isolating cosine of z, so that's going to be giving us e to the iz plus e to the minus iz over 2. So that comes a relation between cosine function and exponential function actually. Okay, and now let's do the same stuff with the with subtraction actually. So I'm just going to write e to the minus iz on the top equals cosine of z minus, I'm sorry, I should have written, let's just write the first equation first, plus I times sine of z, and we have e to the minus iz as cosine of z minus I times sine of z. And now what we have to subtract it down, so sign changes, so we are again getting rid of these two cosine terms there, and what we're gonna get here is e to the iz minus e to the minus iz equals 2I sine of z. And again isolating sine of z here, so sine of z is gonna be e to the iz minus e to the minus iz over 2I. So that's how it looks like. And now let's just use them up here in the reciprocal of I'm talking about this one. So basically we can just write them up. So we have e to the iz minus e to the minus iz over 2I over e to the iz plus e to the minus iz over 2. And from here we can say we are having 1 over I times e to the iz minus e to the minus iz over e to the iz plus e to the minus iz. And now from there we are having tangent of z as 1 over I times e to the iz minus e to the minus iz over e to the iz plus e to the minus iz. And from our assumption, we know that theta is equivalent to tangent of z. So basically we can just replace here with theta and multiply with I both sides in order to get rid of that reciprocal I on the right hand side. So I theta equals e to the iz minus e to the minus iz over e to the iz plus e to the minus iz. So far we are there. Okay, and now what I'm gonna do next here is let I e to the iz equals x, right? So what that's gonna be giving us, I theta equals x minus 1 over x, because e to the minus iz is 1 over x, we know that, and we have x plus 1 over x, and that can further be written as x squared minus 1 over x squared plus 1, right? So basically we are having I theta equals x squared minus 1 over x squared plus 1. Now multiplying both sides with x squared plus 1, so we have I theta times x squared plus 1 equals x squared minus 1. And now we can just expand this up, multiplying this to this and this to this as well. So we have I theta x squared plus I theta equals x squared minus 1. And now we are just gonna add 1 both sides and subtract I theta x squared both sides as well. So we have 1 plus I theta equals x squared minus I theta x squared, and we can factor out x squared on the right hand side. So we're gonna have 1 plus I theta equals x squared 1 minus I theta, and just dividing both sides with 1 minus I theta, we would be having x squared as 1 plus I theta over 1 minus I theta, right? And what we have assumed our x as, we had our x as e to the iz. Now we can just square both sides in order to get e to the iz of x. So basically it's your e to the 2iz equals 1 plus I theta over 1 minus I theta. And now taking natural logarithm both sides, so we have natural logarithm of e to the 2iz equals natural logarithm of 1 plus I theta over 1 minus I theta, and we know that it's gonna be 2iz equals natural logarithm of 1 plus I theta over 1 minus I theta. Dividing both sides with 2I, so it's gonna be z equals 1 over 2I times natural logarithm of 1 plus I theta over 1 minus I theta. And from our very early assumption, we know that z is arctangent of theta. So basically its arctangent of theta is coming out to be 1 over 2i natural logarithm of 1 plus I theta over 1 minus I theta, and hence proved. That's it. So that was amazing, guys. And yeah, it was an independent video in which we had just proved this identity down. Okay, so again, guys, if you got to learn something out of it, please make sure to like, subscribe and share. And just make sure to just come up in my next video, because I'm just gonna bring a lot of things, like a lot of videos like this, and I'm sure that you're gonna like all of them. Okay, so goodbye, guys, take care, love you, and just have fun. Have fun of your life, just enjoy each and every moment. Goodbye, guys, love you, take care.